An alien world stolen from another star? And could it provide an unlikely home for life 100 billion miles from the sun? Take a look at the night sky. The stars appear fixed. But look for longer, and you'll see a handful of the points move. These slow-moving points of light are the planets, the giant chunks of rock or gas that orbit our home star, the sun. We thought there were 8. We were wrong.
You know, we think we understand something as simple as our solar system. We found all the planets. And right in front of us, we missed something big.
In 2014, a group of astronomers are studying the Kuiper Belt, a vast band of icy asteroids that sits way outside the orbit of Neptune. Most of these objects move in a neat, circular formation around the sun, but the astronomers are puzzled by a small group that appears to break the rules, swinging far outside the main belt on wild, extended orbits. Something sitting far outside the Kuiper Belt seems to be pulling these asteroids out of line. Something the size of a giant planet. Caltech astronomer Mike Brown hears about the weird observations and is determined to prove the planet theory wrong.
When we saw these alignments of all these objects out there, we thought, oh, everybody's going to say there's a planet. We have to very strongly prove there's not a planet, because, of course, we all know there's not another planet out there. That's ridiculous.
Mike asked his colleague, Constantine, to run a computer simulation to see what effect a night planet should have on Kuiper Belt. Stunningly, the simulation predicts elongated orbits identical to the ones already observed. But the simulation also spits out surprise.
We spotted creatures moving in the rift
set of rogue orbits that are
suspected they might be behind the mass rising of the dead and wanted to investigate. He sent me back to inform Doom Guide Warlock. That was yesterday.
Almost
Nothing since.
Took the simulation results to Mike's office, just a couple of doors down from my office. And I said, look, we've got a huge problem. He said, no. There's an object called 2012 GR30, which has an orbit just like the one you were predicting.
Mike's asteroid fits the prediction perfectly. He searches the records for more and finds another 4 that seem to be in the right area. But just how closely will they fit the prediction?
I remember sitting back and thinking, okay, we're going to right now plot the data, the real observational data, on top of the model. And Mike said, if these two match up, my jaw is just going to drop to the floor. Their theory says they should be right here and right here. And I did the calculations very quickly to see where they were, and I brought them up, and there they are, 1, 2, 3, 4, 5. Right on these lines, exactly where we predicted they should be. The moment we saw this, we went from cautious to, holy cow, this really is there. We have to make sure to tell everybody right away, because it's actually real.
Mike and Constantine had unlocked the solar system's greatest secret. Planet 9 was almost certainly real. It had to be huge, perhaps 10 times the mass of Earth.
We're not talking about something like our moon or Pluto. We're talking about something that is literally planet-sized. And we're seeing its gravitational weight affecting these other objects.
The idea that there could be a giant planet that we've never seen is something I think most people wouldn't have bet on. But the evidence is remarkable.
To prove Planet 9 exists, astronomers need to see it with telescopes. But there's a problem. Computer simulations only give a broad idea of where to find it. And Planet 9 is incredibly faint and very far away.
that's much, much farther out than we ever expected to find planets. It probably spends most of its life in its own elliptical orbit, so far away from the sun that we just missed it.
So, just how far away is Planet 9? The only way to truly appreciate its vast orbit is to build a scale model, perhaps the biggest working scale model in the solar system ever attempted. Planetary scientist Kevin Walsh is here to call the shot.
Sorry, folks. I wanted to get another drink of soda. My mouth was getting dry.
We're going to set the scale of our mini solar system today. So everything is scaled off of its relative size compared to the size of the sun.
Kevin quickly paces out the position of the inner rocky planets. All four sit within 60 yards of the sun on the scale, and each planet would appear no bigger than a peppercorn. To make this a working solar system, we need to bring on the drones. Represents a different planet, and the orbital speed have been scaled so one Earth year takes just 30 seconds. Already it's clear how tightly bunched these inner planets are, and how the closest planets orbit faster than those farther out. Far beyond the tightly packed rocky planets lies the first of the gas giant planets, Jupiter, just over a football field from the sun on the scale.
So after this 400-foot walk, we made it to Jupiter, the largest planet in the solar system. But even by this size scale, Jupiter is only about the size of a lollipop.
Another football field lies ahead on the walk to Saturn.
We look back across the lake bed. I can barely see the drone covering a huge distance.
The trip out to Uranus is bigger still. 3 football fields, or the length of the aircraft trip.
Turns out there's a lot of wind in the outer solar system. So I have to yell. Surprising amount of wind in the outer solar system. Tumbleweed, rattlesnake.
After Uranus, it's about 200 yards out to Neptune. Before the discovery of Planet 9, we thought Neptune was the farthest planet from the Sun, around half a mile on the scale of our model. But Neptune's distant orbit is nothing compared to the orbit of Planet 9.
So here we are. We made it to the orbit of Neptune. We're only at the tip of the iceberg. We need to stop measuring in feet, and we need to start thinking in miles. We need a car to get out to Planet 9.
Planet 9 swings out on a highly elliptical orbit. Its closest pass to the Sun is a whopping 19 billion miles. That's 6 times wider than the orbit of Neptune. But at its farthest point, Planet 9 is 112 billion miles away. And on this scale, that's an incredible 18 miles from our kickball-sized Sun.
So we're here, end of the road. Driven about 18 miles from where we first started setting up the solar system. But in the scale of the solar system, it's over 100 billion. 100 billion miles to get out to the furthest part of Planet 9. To the scale, we don't know what Planet 9 would look like, but it's probably about the size of a BB. This is the challenge for our astronomers. How do you see a BB from 18 miles away? This is what we have to do.
It could take years for our telescopes to see. You dare disrupt the ritual? Until then, scientists can only speculate on what this mysterious world might be like.
We're in this wonderful moment right now where we suspect that Planet 9 exists, but we really have no idea what it's like. And that means our imaginations can run wild. They're informed by science, but I love it when creativity takes hold.
So what are the options? Science suggests three possibilities. The first is astonishing. Planet 9 could be made of the same materials as the Earth, but 10 times more massive. A rocky super Earth. But what would this giant rocky planet look like so far from the sun? A bizarre volcanic planet scarred with fire somehow emerges from the cold darkness of deep space. In 2016, astronomers released astonishing evidence of a missing ninth planet on the frozen edges of our solar system, 100 billion miles from the sun. Until our telescopes find it, we can only guess what this mysterious Planet 9 is like. But the first option is perhaps the most surprising. Planet 9 could be made from rock, just like the Earth, but 10 times more massive, a so-called rocky super Earth.
When we looked out into the universe, we realized that the most common type of planet in the entire galaxy is something we don't have, something called a super Earth.
Cannonball, watch open. Nose.
The Kepler Space Telescope finds alien worlds by measuring the tiny dip in light as a planet passes in front of its host star. Most of the alien solar systems Kepler finds have super Earths. So how come our star doesn't have one?